Welcome! In this series of videos, we will look at software add-ons for the PowerBasic Windows and console compilers. Today we will look again at the SQLite database engine library to run SQL queries from your applications. This was our application at the end of the last video. We created a PowerBasic console application which is set up to use the SQLite 3 DLL to allow us to connect to SQLite databases. What we have done so far is fine as a proof of concept. However, once you start connecting to databases, you'll find you want to create more applications that do something very similar. So when you get to this point, it's ideal to start creating libraries to make the writing of your software easier and faster. So that's what we're going to be doing today. The first thing we're going to add to this work directory are some existing libraries, which we've created in previous videos. So we're adding the PB file handling routines library, the PB sorting library, and the PB array functions library. The sorting and the array functions library are to do with arrays. In our last video, as well as creating and connecting to a database, we created a table and populated it, and then read the data back out row by row. However, there will be times in your applications that you wish to read all the records in a table and put them directly in an array so they can be used within your application. So we're going to create something in our SQLite library to allow us to read all the data within a table into a two-dimensional array. So let's go and have a look at the code. So this is the beginning of our application where we're declaring all the functions that exist within the SQLite library. We're going to take all of these out of our code and put it into a separate library, so that separate library can be included in future applications. And to make our code even more generic, we're going to create a couple of constants in this main file. One for the name of the database that we want this application to connect to, and another to name an application log. It's always quite useful in your applications to create application logs where you can write to that log to indicate what stage the program is actually at. Also useful for putting any errors out to that log. So here are those two constants, dbName containing the name of the database and log containing the name of the application's log. We're now going to create our SQLite library. We'll call this SQLite lib. And within this new file, we're going to put all the declares we had in our original application, plus the constants we had for SQLite. So any additional libraries to connect to the SQLite 3 DLL will be put inside this file. And we will save this file into our folder. And we can now remove all these declarations from our main.bas file. As we've added 3 existing libraries to our folder, we'll need to include them here as well. We only need to include the file handling and the array functions, as the sorting library is a dependency of the array functions library. As we want to move towards creating generic functions to connect to our database and perform functions upon it, we're going to be changing some of the code in here as well. With SQLite, when you call the SQLite 3 open, it will either create or attach to a database. If the file you're referencing does not exist, then it will attempt to create that file. If the file already exists, it will attempt to connect to it as a database. However, I'm going to create in our new library 2 new functions, one for creating a database and one for opening a database. This is to ensure that when you click Create, it will only create the database if it actually does not exist. And if you call the Open Database command, it will not attempt to create a file, but it will rather attempt to connect to an existing file and will raise an error should the file not exist. This gives you a little bit more flexibility. So we're going to remove this open or create the database file function. And we're going to put a call to this new function we're about to create called createDB. It will take three parameters: the path and name of the database to create, the handle of the database which is going to be returned, and an optional error message should the database not be able to be created. So we're going to declare a couple of local variables, the error being one of them. And the other one is a SQL string. This will allow us to run SQL against our database, using this as a variable. So let's go and create the createDB function. So here is the skeleton of our new function taking its three parameters. This routine is intended to create a new database and return true if it has been created and false if it already exists. So we will first test for the presence of this file. If the file already exists, then we will populate the error variable with the wording "file already exists." We will make the return of the function false and we will exit this function immediately. If no file does exist, we will go ahead and call the SQLite 3 option to open our database. This will attempt to create the database. And as long as we get back the constant SQLite OK, then we'll know there are no errors. We'll return function equals true. If it returns anything other than true, then we're going to call another of the SQLite 3 DLL functions called errorMessage. This will return a string value saying what in English the error actually is. This new function takes a single parameter, which is the handle to the database. So if we have got this far, we'll know the database has been created. So it would be ideal at this point to send a message to our log to say that the application has now started. So right at the beginning of our application, we're going to test for the presence of our log file, and if it does exist, we're going to erase it using the kill command. And then, calling a new function called log, we're going to send a message out to say that the application has now started. So we will create this new log function in our library. This will take a single parameter, which is the string we wish to write to the log. We're doing a conditional compilation here to test if we're compiling under the console compiler. If that is the case, then we are sending a message to the console, so it appears on screen. If that is not the case, then this piece of code will not be added in to the application. Next, we are getting the next free file handle and attempting to open our log for append. This will create the file if it does not exist, or append to the file if it already does. So now the database has been created, do we need to create any tables in the database? So our next command call is going to be to a new function called openDatabase, taking as before three parameters. And if this does return true, we want to call two new functions, one to create tables and one to insert data. We'll create these functions in a moment, but let's go and create the openDatabase function in our library. This is going to be another fairly straightforward function, taking, as I said, three parameters. And we're using the SQLite open once more. Since we know for sure that the file already exists, we can then go ahead and just call SQLite 3 open and getting back its return code. If the return code equals SQLite OK, we can return true. If it does not return OK, then we can return the error message in the error variable. So now that we have possibly created and opened our database, we can now go ahead and create any tables. At this point in time, we'll know that the database has been created. So there will be nothing in the database in the way of a SQL schema. So we can now create the createTables function within this file, the .bas file. Now we already had a createTable function within this file. Now we're going to be removing this one because we may be creating multiple tables. So let's take this piece of code out of the application. And as we may be creating multiple tables, we're going to create an array of strings to contain our SQL. In this case, I'm just going to create two tables. But this can be easily extended by increasing the size of the array and putting in more SQL statements. So we're doing a createTable if not exists, and we're creating a table staff and a table accounts. So there will be two tables in this database. Next, we're going to use a for next loop to create each of these tables using a new function called execute SQL. The for next loop will step through each row in the string SQL array, and it will call the execute SQL function, which we've yet to create, passing three parameters: the database handle, the SQL we wish to execute, and a string containing any error to be passed back. If execute SQL returns false for any reason, we know there's been an error creating the SQL, and we can log a message to our log to say the table cannot be created, and the error message will tell us why. And at that point we can exit the function immediately. If we get through all the SQL statements, we will return the value true. So we will now need to create an execute SQL function within our new library. And here is the skeleton of this new function with its three parameters. The idea behind this new function is that each time you wish to run a piece of SQL against your database and are not expecting back any data, all you really need to know is, did the SQL work or not? So this will be ideal for creating tables or for commanding something to be, for example, deleted. So we're going to make use of the SQLite 3 execute command. If this returns SQLite true, then the function has worked successfully and there are no errors. If it returns anything other than SQLite OK, then we're using a pointer to pick up our error message as we did in the previous video. We're then populating our error string with the pointer to that data, and we're also calling a new function called SQLite3free to free up any memory that SQLite was actually using for this particular error. So now that we have completed this create tables function, all our tables should now be created automatically within our database. So back to the PB main function. The next function we want to create is insert data. This will insert any standing data that you want set up inside your database when your application runs for the first time. So now we can go ahead and create this new function. So here is the skeleton of our new function, taking its single parameter, which is the database handle. We've created three local variables. First of all, a string array of 3 elements. Next we have a long value, which will be our pointer to each of the elements within the string array. And finally, the ubiquitous error string should there be any errors. Next, we're going to create each of the insert statements and put them into our array. And next, we're going to use a for next loop to run through the SQL array and execute each in turn, calling the execute SQL function. As before, should any call to the execute SQL return false, then some kind of error has occurred, and we will push that error out to our log and return false, exiting the function immediately. Should it get through all the elements within the string array, we'll return the value true. So back in the PB main function, we can then look to complete the handling of the if conditions. So we have an if is true for create tables, so we'll need an else. This is telling us there's been a failure to create all of our tables. So we'll just put a message out to the log and close the database. So this is another new function for closing the database down. So let's nip back into our library and create this new function. And again, this is not a complicated function, taking just 2 parameters, the database handle and a string to pass back should there be any error closing down the database. And as before, we're calling the SQLite close command and using the error message function in SQLite 3 to return in English what the error actually is. So we also have an if block when we're opening the database. If that returns false, we'll need to handle that as well. And we can send out a problem opening the database and the error message that's been returned. And we can attempt to close the database down just to ensure that SQLite closes off any memory being used. The other condition we'll need to handle is if createDB returns false. In other words, the database already exists. So if we do get a false back from that function, we know the database already exists, but it's possible there is some strange error. So if the error does not equal file already exists, then we will print out a message to say there's been a problem creating the database. And we can print the error out to our log. If the error does equal file already exists, we know the database already exists, so we can just open it up. And as we've done before, if we have a false coming back from OpenDB, we can say we couldn't open the database. So we get to the end of all that code, we know our database has been created or opened, and it has all the tables and data necessary within the database. So now we can start looking at reading data from the database. So there is now some code we can remove from this existing file. And this is where we're going to pull information back from a table and place it in an array. So we've dimensioned a local array called data. This is the array that will hold our data when we run our SQL. And this is the SQL we wish to run. We want to select the ID, the name, and the age from the table staff table. And to do this, we're going to be using a new function in our array called recordSetAsArray. Once this function is created, it will make it much easier to get data out of your SQLite database, just by calling recordSetAsArray with your SQL and an array into which the data is to go. So let's go and create this new function. So here is the new function taking its 5 parameters. The 5th parameter I'll cover in a moment, which is an optional one for skipping headers. So we need to run the query the user has requested and return the record set as an array. So we're going to need some local variables. We have a return code as normal, and a variable for the error message, and a statement ID for the statement ID being run against the database, and we're also using the tail variable. Again, this is not yet used. Our second set of variables are first of all an array for the data, and we have a separate array for the column headers. These are the names of the fields. So since the SQL will vary, the number of columns returned is undetermined. So we'll need to work out how many columns are coming back from the SQL in order to dimension our data array. And we're going to use a column counter, as there will be a for next loop involved in here. And we're using column name as a string to hold the name of the columns. And we'll also need a row count in order to dimension an array for the number of rows. And we'll step through each row one at a time. And finally, we have a pointer used for pulling back the name of the field. That is the column name. So as there is an optional parameter, we'll need to test to see whether that has been provided or not on this particular call. So we're going to use the isMissing command. If the skip headers variable is missing, then we will set with headers to be true. If not, we will set it to be whatever value was passed in. As we did before, we're going to use a prepare statement to prepare our SQL for SQLite. We covered this one in the last video. As before, if it returns anything other than SQLite OK, then some kind of error has occurred, and we will pass that back to the calling function. Next, we need to work out just how many columns have we got in this particular piece of SQL. So SQLite 3 has a new function called column count, which, as the name suggests, given the statement ID, it will return the number of columns. If that column count is 0, then no columns have been returned. And we can finalize this particular statement and exit the function returning the value false to the calling routine. Next, we need to work out the names of the headers. So we're dimensioning our headers array using the columns count value. And we're going to do a conditional call on a new function called getHeaders. If the withHeaders variable is true, then we will attempt to get our headers. If it is false, then we will not attempt to get our headers. So before we go further in this function, we'll create the new getHeaders function. This function takes 3 parameters: the database handle, the reference to the headers array, and this SQL which we were attempting to run. We're using 3 local variables, one for an error, one for the table name, and one for the SQL. Our first task is to extract the table name. I'm taking this particular approach as there is a function to return the column name in SQLite 3. Unfortunately, I couldn't get this one to work. So, to save any effort, I'm taking an alternative approach. So first, we need to extract from the SQL the name of the table. And I'm using the parse command twice to pull that information out, looking for the from statement. Next, I'm using a piece of SQL. Select name as the column name from the Pragma table info table, and giving it the name of the table I wish to use. In this case, this one here. So this function can be used for any SQL string you run. Next, I'm going to make another call to the record set as array function, which we're in the process of creating. And its optional parameter is false, as we don't need to get the headers for this one. All we need is the data. So now that we've got that one out of the way, let's go back to our record set as array function. So by this point, we will have got the headers. What we do not know yet is how many data rows we have. So I'm taking the assumption there will be possibly 1,000 rows of data. So I'm initially dimensioning our data array to be 1,000 by the number of columns. Next, we're checking for the headers. If the with headers is true, we're inserting the column headers, which we have in our headers array, to the very top of the data array in the 0 element. Next, we're going to do a do loop to pull back the information from SQLite for each of the rows that our SQL is going to return. This is going to use the same code as we used in the previous video. We're running SQLite 3 step with the statement ID, and we're testing the return code that comes back. If the return code is SQLite row, then we have successfully picked up data and we can increment our row counts. If the row number is greater than the size of the data already, we can add on another block of data to our data array. You could add one row at a time onto the array, but that would be very inefficient. Adding 1,000 rows onto the data array at one go is much more efficient. Next, we want to pull the value of each of the columns of information out of this row. So another for next loop. This approach will have the advantage in the fact it doesn't matter what type of data is in each of the columns. It will treat all of them as text. So we're populating our pointer field variable with the output from the SQLite 3 column text function. This, as I said, returns a piece of text, and we can then populate our array with that value. And then we can free up that variable in SQLite. So if we get back SQLite done, then there is no more data coming back from the database. At this point, our data array will be larger than it actually needs to be. There will be a lot of blank lines at the bottom, because we initially dimensioned it as 1,000 rows, and every time we exceed that, we add another 1,000. So there could be quite a number of blank rows at the bottom of our array. Now, in the libraries we've added today, there's another function called ArrayTrim2D. This function was designed to remove these extra rows from the bottom of two-dimensional arrays, so we'll just make use of that. And if we get any other value coming back, we've got some kind of error. So we will put a case else command in to return that there's been a problem reading the data in our error variable. And once we've completed the loop, we can then do our cleanup to finalize our statement. So now that we've completed this generic function, it can be used for any SQL call that's going to return one or more rows of data. And as it's returning in an array, you can test the size of the array, both columns and rows, quite easily. So now that we've got the data back, it's sitting in this array. So in order to see what we've actually got, we can use a dump command to dump the data to a CSV file. So we've got another function in our library which we can use quite easily to save any additional coding. And that function is called save the array to CSV file, taking 3 parameters. The name of the file you wish to create, the array you wish to populate into that file, and a value true or false. The true or false is an optional parameter to say whether you want to start at the 0 element or not. If this is true, we will start at the 0 element. If it is not specified or is false, then we will start at the first row, element number 1. So if we go back to the beginning of our application, the one additional thing we'll need to add in are 3 constants, which are needed for one of our libraries but not actually used within this application. These are mainly used for index searching. So if we attempt to compile our application now to make sure we haven't made any mistakes, and it compiles quite cleanly, and if we have a look in our folder, we have a testdb file there at the moment, so let's remove testdb. And we can attempt to run our SQLite starter executable. We double click on that, we'll see it's creating the tables, reading the data from the database, and it's now saying it's saved the file to disk. So we can now see there is our testdb file, 12K in size. We can see our application log, which if we open it up, we can see the application was started at 1431, creating tables, reading data from database, table data saved to file. Ideal, we should probably put a application complete message in. So we'll put this at the very end. And just to ensure everything's okay, we'll call the closedb command. So let's have a look now at the data.txt file. Did we actually pull any information out of the database? So there are our 3 records which we had inserted into the database. We have our headers on each row, and we have each of the data rows. The Tom Smith, the Jane Thompson, and the David Jones. So in summary, what we've done today is we've created a library which can be used for future applications that need to connect to SQLite 3. If we look in our main starter.bas application, we'll see there are only 3 functions now: the pbmain, the createTables function, and an insertData function. The createTables function is actually calling a generic library function called executeSQL, designed to run SQL commands with only a true or false coming back. We have an insertData function whose job it is to insert data into tables. Again, using the executeSQL function, which is in our library. In our library, we've created a number of generic functions to create a database, to open a database, and close that database. We can also execute a SQL statement, and we can call a record set as array, which allows us to run a piece of SQL against any database and return an array of the data. Once that array is inside your application, as with any array, you can process it quite happily. So it should now be easier to access SQLite within your own applications. Hopefully you'll find this code useful, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.